Welcome back to video 2. We're now going to take a look at setting up the document class for our game, and we're also going to look at spawning our ships dynamically, which means spawning them using code instead of just dragging them on from the library, because there's only so many you can spawn that way. We want them to spawn over time at different speeds and rates and so on, so we're going to use code to do that. But first we're going to set up the document class, which is basically the ActionScript file that controls the main stage. So this main stage, the main SWF, is a movie clip. So it can have an ActionScript file assigned to it just as our ship could have in the library. And to do that we go to the properties of our document, so we click on nothing and go to properties. And here we have the box for the class, which if you highlight it says document class, which is what we're creating. If you're in CS5 you can click the pencil to generate it again. All I'm going to do is type the name, so it's going to be called game. I'm just wondering if you need the AS as well. We'll come back to that if we do. And I'm going to make a new ActionScript file. And my phone's going to beep. I'm going to hit ActionScript file. And there we are. This is going to be our document class. So we're going to start it exactly the same way as the ship AS. So package is the first word. And let's open that package there with curly braces. And this time, instead of importing the sprite, we're going to import the movie clip class. So we're going to import flash.display.movieclip, because our main stage is actually a movie clip. Believe it or not, it has a timeline and we can draw onto it and so on. So it's a movie clip. Next is to set up the class. So we do public class game, and it extends a movie clip. Extends movie clip. Open the curly braces to show where the class contents are going to go. And we're going to have a little space for any important variables that we need, so we'll leave a comment. Variables, etc. I'm not actually going to make any just yet. And then we'll have the constructor as well. So public function game, because it's the class name. We're not putting anything in the brackets just yet. And in there, I'm just going to trace here just to check it works. Made at game. And we're going to save that using the class's name. So that's going to be game.as. Hit save. And let's just check it works by testing the video. Made a game. There we go. So we're now set up with a document class that controls our main movie clip. Now, although we do have the document class, I'm still going to program in the timeline of the main video, because at some points it makes more sense to do that. If you're working across 10 frames and you want something to happen in the 9th frame, it's a lot easier to just jump to frame 9 and put some code in than it is to faff around in your document class. So we will use the document class, but it's not going to be the be-all and end-all of our game. Just save the game file. Okay, so let's now use our document class to spawn some spaceships. So straight away in the constructor, I am going to spawn a ship. I'm just going to spawn one ship in the middle of the screen. And to spawn a ship, we're going to need to make one, and the keyword for that is new. But before we do that, we're going to need somewhere to place it. So I'm going to make a variable to hold this ship. So I'm going to do var s equals new ship, because that's what we're making. We're making an instance of our ship class. So I'm going to have a variable called s, just short for ship, and it's going to be a new ship. There's nothing in the brackets there because our constructor for ship doesn't take any values. So hopefully now when we do that we should get made a game and made a ship traced out. If we just save that, run our file. That worked, but notice there's no ship on the screen there. and that's because we haven't added it to what's called the display list. And the display list is basically a big long list of all the contents of a movie clip or a sprite or a display object. And to add something to the display list, there's a keyword, or a couple of keywords. It's add child. So we need to add a child to our movie clip, to our main scene. We're going to add child, all one word with capital C, and it'll go blue. Open brackets because it's actually a function of this object. And then we type what we want to add, so we're going to put S in because S is the variable holding our new ship. And I'm just going to comment that there, comment both lines. Make a new instance of the ship class. And here we'll add the ship to the display list. Now hopefully, when we save that and test the video, you can see right at the top there we've got a ship flying along the top. And that's because we haven't actually given the ship a position or a rotation, so it's just defaulting to 0, 0 position, which is the top left, and a rotation of 0, which faces to the right. So we can now affect that directly by affecting S's properties, just as we did in the first series of tutorials. So we can do, just comment it, position and rotate the ship. To position it, we access the X and Y properties. So I'm just going to do s.x equals, let's say, 200 pixels to the right. s.y equals 300, so it'll be 300 pixels down, 200 across. And finally we'll rotate it with s.rotation equals 45, so 45 degree rotation. Save that, test it, and there we go. Our ship spawned down the screen and it started going at 45 degree angle. So that all seemed to work as expected. So we've made our first ship, but what if we want to spawn lots of them over time? Well, we can do that by using pretty much the same piece of code here, but I'm not going to do it in the constructor. I'm going to cut this code now, so I'm going to cut that out, and I'm going to instead add an event listener to spawn a new ship every frame. So I'm going to add an event listener here. This is adding to my main movie clip, the main game file. Add event listener, event.enter frame, and we'll call it loop. We're going to need to import this event class again. So let's import flash.events.event. And outside of the constructor, we'll make the loop function. So function loop takes an event, just as our ship did, and I'm going to paste the code back in. So this is going to make a new ship every frame. Let's just get some spacing down here at the bottom. Hopefully now if we save that, test the video, we get a ship every frame from that same position. Which, okay, it's doing something, but it's not much use at the moment, and that's because of these positions and the rotation. They're the same every time. So let's throw some randomness in there. The position we'll do math.random times, and let's try stage.stage width. That's the width of the main stage that you've drawn out on your workspace. And similarly here we'll do math.random times stage.stage height. And finally the rotation, give it a random rotation. Math.random times 360, so any kind of angle there. Save that, let's test it and hope it works. And we're getting lots of ships. Our output is going ballistic. There's so many comments coming, traces, that it just doesn't really know what to do. And it's generally having a good time. I'm just going to recompile that. start it again. So if we left that going, that's eventually going to lag because it's just spawning one a frame. There's no control to that. So we should do something about that really. And what we can do is actually make use of the I keep saying playlist, the display list, to ask it how many children it currently has, which sounds a bit odd to begin with, but you'll soon come to use the word quite freely. So we're going to limit this spawning. So we'll go to the top of the spawn and we'll say only spawn a ship if there are less than 100 already on screen. We can do that by asking the display list how many children it currently contains. And to do that we'll have an if. Again, this is using techniques from the last tutorial series, so make sure you've watched it. And we'll say if num children, which is a property of this display object, it's directly asking the display list within it how many children it has. If num children is less than 100, and we'll use what we've already got in there, and we'll just close the if at the end of all this spawn code. And we'll just use the auto format there to make it all nice and pretty. And let's give that a go. So save it, run, and hopefully we reach a limit. Yeah, so look, they've stopped spawning now, and because they're all moving in a straight line, they're eventually gone forever. But we're not getting any more than 100 spawn, which helps our computer because we don't want to fill the RAM and crash the computer by having billions of ships on there. The game will work slightly different because eventually you'll die if there's too many on stage anyway, so it's not going to be too much of an issue. You just got to be aware of crashing your computer really when you're using spawning in such a way. Okay, so it's a bit boring now. The ships sort of fly off and that's it, they're gone forever. So we can have a look at making the ships a bit smarter. This is where a lot of maths might come into it. Kind of just going to wing it at this point and then explain it later on. So let's have a play around in the ship class. So if we hop right into the ship class, just as we left it last time, I'm going to change it a little bit so that the ships actively move towards a location. So we're going to need a different property for the ship. We'll add a target. We'll add private target, and it can be a point. Oops, sorry, needs to be a variable. Private var target, and it's going to be of type point, which we haven't used before. A point is basically an x and a y, just saved in the same variable. So we're going to have to import something else here. Let's see if I can remember what it is. I think it's just display again. Flash.display. Or is it? Let's try. Let's see if display likes it. .point. No, it's not display. Flash.geom.point. That makes sense. There we go. Flash.geom.point. I'm guessing it's for geometry. So we've imported point. We've told this ship that it's going to have a target that's a point, and now in the constructor we're going to set that target. So we'll set the target location of the ship. So if we do target.x equals math.random times 500, so anywhere on the screen, target.y equals math.random times 500. Now you might be wondering there why I haven't used stage height and stage width. And that's because at the moment this ship class doesn't have a reference to the stage. The document class is different because it's actually controlling the main document, so this has a stage to work with, whereas the ship at the moment doesn't. So we'll have to feed that into it later on. Okay, so we've got a target. Let's do something with it. So our ship down here now needs to move towards the target we've set. So we're going to use some trigonometry, some Pythagoras to figure out which way we need to be going. So the first thing to do before we actually move the ship, we need to figure out or correct its rotation. So let's point the ship at its target. Now this is going to be an instant snap towards its target. It's not going to slowly turn towards the target as they do in the final game, because the maths for that is something we're going to have to spend a little bit of time on. For this case, we're just going to instantly rotate to face something. And to do that, we're going to need trigonometry. We're going to use the difference in the x positions, the difference in the y positions, and then figure out the angle based on using the arc tangent, if you remember your trigonometry from high school. So we're going to make two variables here. We'll make a variable called dx, which stands for difference in x, and that's going to be the target.x minus the current x minus x. So we're taking where we want to be, we're taking where we currently are away from where we want to be, and that gives us the difference between the two locations. Do the same for y, so we'll have var dy, the difference in the y, and that's target y minus current y. And then we can calculate the angle using the arctangent function that's built into the math class. So we've already used cosine and sine here. We're now going to use the reverse of a tangent. So instead of putting tan, we're going to use the atan. So put var angle equals math dot atan, and we use atan 2 because atan can go off exponentially. It messes up. I think it's based on the segments of a graph. I'm not the biggest maths genius in the world. It's a long time since I've done it. I just get by, but this works. And we put the two numbers it's asking for there. It wants a y and an x, and we've got a dy and a dx, so we'll feed them in. And that's going to return an answer in radians, so we need to convert that. Just as we've done below, we've converted to radians from degrees. We're going to convert here from degrees to radians. Hopefully that makes sense. In fact, we wouldn't even need this variable. We could pass this straight into the rotation of the ship. So we'll do that in a second. So we're going to take the result of that atan 2. We're going to divide it by math.pi, and then we're going to times that by 180 to convert it to degrees. And then underneath we'll do rotation equals angle. Let's see how that does. Now the problem is we're not really going to know when they've reached their goal, so we're going to have to do some more maths in a second. I'm just going to make sure that this actually compiles and runs. Nope, didn't like that, so I've done something wrong. Let's have a look. Cannot access a property or method of a null object reference, and that's because I didn't make my point, because I'm getting a bit sleepy at this time. So before we set the target x and the target y, we actually had to make the point. So we'll do target equals new point. And point is one of these classes that you can actually pass values straight in to the constructor. So what we could do here, instead of setting the targets x and y individually, we can actually copy this and paste it in twice. So we'll paste it once, do a comma to separate it, and paste it again. So we're making a new point and we're passing two numbers to it straight away. Hopefully now that'll compile, and it does. And we've got a ship here that's a bit confused, and they're all getting confused when they reach the point. So that kind of shows us that it's working, because they're getting to the target and then they're going a bit crazy. They don't know where to go. So it's obviously doing something. What we can do now is we'll control it. So we'll make it pick a new target when it reaches its original target. I'm just going to drop a comment in here. Move in the direction the ship is facing. And here what we're going to do is figure out how close to our target we are, and if we're too close we'll pick a new target. So we'll calculate the distance to target, and to do that we're going to make use of the dx and the dy again to do some Pythagoras. So we're going to make a new variable to store the hypotenuse, which let me just quickly show you in a new flash file. The hypotenuse of a triangle, if you bear with me a sec, just draw one out for you. So we've got a right angled triangle with white lines, yay. We've got a right angled triangle here, connected. And obviously a triangle has three sides. We've got the two that make the right angle, and then we've got the hypotenuse here. And what Pythagoras says is that the rules of a right angled triangle is the square of both of these added together makes the square of the hypotenuse. So we square the length of that, we square the length of that, and we get the squared length of that. I didn't explain that very well because I'm getting very tired, but we combine the square of that with the square of that, and that gives us the square of that one. If you really fancy researching it, just put triangle maths into Google. I'm not going to save that. I'll just save this as we go. So var hip for hypotenuse equals, and we'll use math dot square root, so sqrt is the square root, and we need to combine the square roots of x and y, or dx and dy. So in brackets again I'm going to do dx times dx. We're not combining the square roots, we're combining the squares. My brain's fuzzy. So we've squared dx there, and we're going to add square of dy. And that's going to give us the length of the hypotenuse of this triangle we've made. And now we're going to say if the hip is greater than, let's say, less than 5 pixels, not greater than. If it's less than 5 pixels, pick a new target. And we do that with an if. So let's open an if. If hip is less than 5, open curly braces for the if. I'm just going to copy these two target lines that we commented out earlier. Copy them, stick them in there, and uncomment them both. Just a quick tip about uncommenting. You can select lines that are commented and click this button here to uncomment them. And hopefully, fingers crossed, that'll work first time. So now the ships shouldn't get lost when they reach the target. They should instantly swap to a new one, which they seem to be doing. They're whizzing around all over the place. So it's a bit unrealistic how they turn, how they're sort of turning around so fast. But it's adding an extra dimension to our ship class. They're not just wandering off in one direction. They've got some kind of intelligence. Let's just quickly change this. Let's make them target the mouse instead and see what that feels like. So I'm going to use, actually we're not going to do that because that relies on dragging in the stage coordinates, so we'll leave that for a future video. I don't want to rush these things. Make sure you've understood everything in this one. You understand the concept of a document class, even though we haven't really done much with it. So it's the AS file that controls the main stage. You understand the concept of using stage, so we've actually pulled in values from our stage, the width and the height, and we've spawned these ships dynamically onto our stage. So that's what's going on in the document class there. And then just to make it a bit more interesting, we went back to the ship and changed it so that it would move towards a target. That wasn't the main goal of this video, but it's a nice little addition. Thanks for watching so far. I'll see you in the next video.